I am Okada from Line OA Dev 1 team. So OA is short for official account. In Japanese, it's koshiki account. And in that team, I am involved in the backend development of the official account. I will be talking about technical matters regarding Line official account. By the way, how many of you know the Line official account? So who are familiar with Line official account? Could you raise your hands? Thank you. So quite a lot of you know about this account. That's good. Actually, the Line Developer Day event has its own official account, and it offers session information as well as you also can register through this account. And so it's nice that you know about the official account. But to explain what it is, businesses and local governments, etc., can open their own Line accounts and communicate with Line users. It is Line's B2B service. The Line official account is used by many people and organizations, both individuals and businesses. And including non-active accounts, we have globally 11 million accounts globally. Also, the official account has a feature called broadcasting. And like user reaction of events, such as opening of messages and clicking of links within messages, the peak traffic is estimated to be around 500,000 per second. So Line official account is a service that generates a significant amount of traffic. We offer Line official account manager, which is a UI to manage these official accounts. We have web version and mobile app versions. And what you see here is the web version screen. From this UI, the operators of official accounts can send messages and also view statistics to check the reactions to the sent messages. Also offer customer support through one-to-one chat feature. So among the features of the Line official account, broadcasting is one of the most widely used. As you can see on this screen, the message to be delivered can be created and previewed on the management screen and sent to the users who have befriended that official account. The broadcasting feature can be used to send valuable information to the users, such as campaign promotions, release information of new products, coupons, to have people come to the store. So these are the use cases where broadcasting is used. And some of you here may have seen stores who are delivering coupons over the Line official account. So using this broadcasting feature, once the messages are sent from the management UI, wouldn't you want to know the users' reactions, such as how many users clicked on the message, to implement further measures to improve the messages that is more valuable to the users? Up till now, we offered message insights such as the number of messages delivered and the numbers of clicks on the links within the message. We call that message insight. And the number of delivered message is other than sending messages to all friends, you can also target the messages based on presumed demographic information such as age group and gender. The number of delivered messages means the number of messages sent as a result of such targeting. However, up till now, the insight information on message delivery, the only insight offered was number of delivered messages and number of clicks. And the statistics were updated only once a day, not real time. We are now carrying out a redesign project to make LINE's overall B2B service, including the official account, more valuable to both businesses and users. So with this, the statistical information which has been provided up till now has become insufficient. So under such backdrop, the other day in September, we released two new features on broadcasting.
The first is on message insights. This is the statistics on message broadcasting, and it has been significantly renewed. So this renewal included the metrics being increased. So number of opening of messages in terms of unique user number, as well as unique user number for those who clicked on the link in the message, and not only just the unique users, but the accumulative event number and embedded video in the message. What is the number of start playing for the video or completing the playing for the video? Such detailed information are now delivered. And these metrics can be provided not daily, but it is real time. The update is done real time. So with this renewal of message insights, I would like to add one thing about the events. So what is measured here is the user reaction events against the messages that are broadcasted from LINE official account. So normal messaging events between users, such as the red message, is not included here as a scope. Another renewal feature is A/B test function for message broadcasting. What this is in one broadcast of a message, various variations can be set for each segment to see what variant was most effective in creating user reaction. And you can check such statistics. And of course, this statistics is also updated real time. In order to do such renewal, the conventional system was not sufficient. Therefore, we needed to develop a completely new event tracking system. However, in developing this, there were many obstacles we had to overcome. Firstly, I mentioned about this earlier, but the user reaction events to the LINE official account message can be very high, 500,000 events per second. That's a high traffic, so simple design would not suffice. For example, when there's spike in traffic, you may not scale, and if there's a failure, there might be data damage or loss. Also, by measuring new events, this means that the LINE application load may be too heavy, and we needed to avoid impact on user experience. Therefore, we needed to minimize the overhead for the LINE app event measurement as much as possible. And of course, the update of these metrics has to be done real time. That is the requirement. And when we make it real time, in most cases, there are some sacrifices you have to make, but while securing the real-time nature, we needed to also secure persistence and robustness. So today, I would like to talk about this new event tracking system which we developed. Internally, we call this message event tracking. That was the name of the project. So I would like to talk about the challenges we faced in this development and how we overcame them. So as you can see in this diagram, this is the overall architecture for this system. So from the management UI, you press on message broadcast, and then it would reach the smartphones of users. I will follow that timeline. So firstly, send messages, it says at the top. So from the management UI, you broadcast a message. And secondly, it is track events. So the broadcasted message, what kind of reactions were made by the users is tracked here. And thirdly, those events are processed in a stream processing manner. Number 4 is batch processing. And lastly, it's not shown on this diagram, but this is the merging of stream process data and batch process data to get the final value. So I will follow this flow. So after talking about the technology of message event tracking system, I would like to also talk about new functions that are developed based on this system. So first, this is about sending message, the broadcasting. So from the management UI, you broadcast a message and it would reach the lineup on the smartphones. And there are many components that it goes through. From the management UI, you press message broadcast, and then it is saved on MySQL, like a job queue. And message delivery server is one component, and this component would pull the messages on MySQL, and it would obtain the messages that can be sent. And those obtained messages, based on it, it would send the request to the message API, messaging API. So up to here is very straightforward. Next, messaging API would send a request to the core server called Talk Server for LINE messaging. And then Talk Server would deliver the message to the friends of the official account. At the same time as sending the message to the Talk server, the messaging API is also storing the metadata on the message on MySQL. And this metadata includes information necessary for gathering metrics. So when metadata is necessary, there are two types of design that are necessary.
The first option is to embed the metadata in the message itself, then send back when a user reaction event is tracked. The second option is to separate the metadata from the message itself and stream join on the server side when a user reaction event occurs. This time, we chose the latter option, that is to separate the metadata from the message itself. Why is that? If metadata embedded into the message is included in the user reaction and is sent back at tracking, the event payload will be very heavy. So we didn't want to choose this option because it may result in bad user experience. However, the option to separate the metadata and the message will make the architecture a little bit more complex, since this metadata needs to be stream joined when aggregating the event. And when the message reaches the smartphone, next we need to track user reaction events within the Line app. When sending messages, one message can hold multiple balloons. So when you see broadcast, one broadcast is one message, and multiple balloons are included in one broadcast. The event tracking SDK embedded in the Line app can gather detailed metrics from each balloon. So balloon 1, there was impression, balloon 2 was clicked, for example. Metrics gathered by the SDK is sent to a component called the event tracker. Then the event tracker sends these metrics into Kafka. So the events that flowed into Kafka are stored in HDFS via Spark streaming. We already owned a data pipeline platform that has been operating stably in a Line Ads platform, which is another B2B platform. So we decided to partially use this platform in the development of this message tracking system. Next, the events flowed into Kafka will be stream processed. This is performed by a Kafka consumer application called the event processor. After linking the event with the metadata stored separately, when the message was sent, the event processor stores the data into Redis and HBase. This streaming part, the event processor, was one of the most tricky parts in the development project. The metadata stored when the message was sent over the messaging API has to be looked up on MySQL to be joined. However, peak traffic up to 500,000 events per second was expected. We wanted to avoid looking up MySQL directly. In such case, generally, a cache layer is used. But in this particular system, the fresh data was important, and there was a characteristic that cache hit rate tends to be low. So using cache was difficult in this particular application. Thus, to reduce the number of requests, we decided to accumulate a certain amount of metadata lookups and refer to MySQL as a batch. After linking the metadata and the events are classified into keys of aggregation units to be written into Redis. By directly referring to this Redis data from the management screen of Line's official account, the statistical information can be updated real-time. Here, counting the unique users became a challenge. To simply get the number of events or the number of clicks, you just have to increment the aggregation unit key in question. However, counting unique users is known generally as the count distinct problem and is difficult to perform efficiently using simple methods. This is because when a user initiates a certain event, to judge whether that user has appeared in previous events to make sure that it's a unique user, we need to keep a hash set of all user IDs that have appeared in the past. So we need a linear space against the number of users, so that makes it inefficient. In services with large user space, such as Line, having this would exceed the main memory capacity limit, making it extremely difficult to provide the unique user count. Fortunately, Redis has an algorithm called hyperloglog embedded. Although I will not delve into too much detail on hyperloglog, it's quite an interesting algorithm. It's a probabilistic algorithm that enables calculation of unique users in constant space, allowing for a certain amount of error. In case of Redis, the standard error is about 0.81%, but this level of error was acceptable to our use case of providing metrics real time, so we decided to go with this. And another point on writing in Redis was that a single user reaction event generates multiple Redis operations. For example, if the user sees a certain message and generates an impression event, we need multiple operations such as pf_add to calculate unique users and incr to calculate the total number of events, and expire to set the TTL because we cannot store this indefinitely. Here, we used Redis Lua Scripting to generate multiple operations in one request. So up till here, I explained about writing information in Redis real time. So while data is written into Redis, simultaneously, the event processor writes into HBase. Raw events logs are written into HBase, and there are three reasons why this is done. The first is, as mentioned before, the real-time unique user count is computed using hyperloglog, so this is prone to some error. By processing raw events log in batch, we will be able to provide accurate unique user count in a less real-time manner. The second reason is to prepare for a feature plan for the future. I will mention about this feature at the end of my presentation. We are planning to offer a feature to have a list of users who generated certain types of events and to target these users. and raw events will be stored to use as original data for this feature. The third reason is, in case Redis data is lost for any reason, we intend to recover the data from the raw event logs.
So, as I mentioned, event processor has the read from MySQL and also put to Redis and HBase. So these are stream processing requiring I/O. So access to external storage means that we have to think about strategy for when the processes fail. For example, in HBase, if there's any region server that is intensively written to, then region 2 busy exception has to be done, may occur, and the writes may fail. So strategy against it is that we prepare another Kafka topic, and we use it as retry queue. So events in retry queue, after a certain backoff, it will do reprocessing until they succeed. So in implementing retry queuing, there's a large line Kafka cluster, and the Kafka operation team develops Decathlon, which is an internally developed consumer framework, and we use this for the retry queuing implementation. So far, I talked about message tracking system, the streaming processing. I talked about the stream processing. Next is about batch processing. The reason why we use stream processing and batch processing at the same time is there are two reasons. The first is, as I mentioned earlier, after the raw logs in HBase, so using the batch processing, we need to do the accurate unique user counting. Next is values in HBase have to be used as persistent aggregated value. By doing stream processing, we have the aggregated value in Redis, but it is stored as unlimited TTL, and to use it as persistent storage, we need to have a big memory for the machine. It's not efficient. Therefore, for the unique user number, so we have the map Redis to read from the log, but for non-unique user, we would import into the HBase the aggregated event count from line ads platform. And for unique user count, we need to have the raw event log in HBase with the optimized schema, and then we need to run the map reduce. So I would like to now talk about the processing done by map reduce job for aggregation of unique user count. So using mapper, there is count columns that are counted by each row key, and reducer would add them up. So this is very simple. And by utilizing the flexibility of HBase schema, we can count the number of columns using user ID. Then we can simply count the unique user count. So far, I talked about how Redis is used for stream processing and how data is stored in HBase for batch processing for persistent storage data. By combining the two, I would like to talk about how we generate the data to be shown on Management UI. In HBase, So I talked about broadcast. So for each broadcast, there is unique ID and date of broadcast. So with this pair as a key, we have the unique click number, such metrics are aggregated. So from the date of the sending of the message until the final batch processing, HBase has the persistent data, so we would use that data first. And after the final batch processing, events after the final processing, we need to get the events from Redis to get the real-time value. And then we would sum them up to have the aggregated value. So that's all about the architecture. And now I would like to talk about the architecture. Once again, the message event tracking system architecture is shown here. So it is scalable and it is robust against failures, and it can also deliver information real time. So it meets the objectives that we had for this development. So I talked about the technology, and lastly, I would like to talk about what we are developing currently based on message event tracking system. There are 3 things we are developing now. First is message retargeting. Retargeting is mostly used in online ads. So what this means is that a message that was sent in the past, if there's any opening or clicks or other reactions to show the interest, and you can create a segment of users with such reactions and interest, and you can send new messages targeting the users on that list so that you can deliver the more valuable information. So this is using Line DMP component. We integrate with Line DMP, which is the targeting platform for Line Ads platform. So in Line DMP, we deliver the events obtained from message event tracking system, and DMP would judge whether they meet certain conditions, and then DMP would accumulate the events in the user segments. And from the management UI, when new message is to be sent, then the LINE official account would send the request to refer to view the user segment in DMP, and then targeting is possible. Next, I would like to talk about the integration with LINE Ads platform. So LINE Ads platform has been mentioned several times. This is the ad broadcasting platform provided by LINE. So there's Smart Channel, which is the chat list, and there's the top banner, a news tab as well. Sometimes you see ads. Those are all delivered through LINE Ads platform. So how we integrate with it is from a LINE official account, messages sent from the account. So users who showed interest, such as opening of message or reactions, you would create a segment for such users, and then you can target such users from LINE official account messaging, but also you can use such list for LINE Ads platform to target the ads as well. And another is a function called lookalike. Lookalike is in marketing, in the ad industry, it's also called audience expansion. So if there's a user segment, then if there are any users with similar characteristics, you would create another segment. So in LINE Ads platform, it's been delivered since 2017. The source segment is called source segment. That's the original segment. So from LINE official account, the messages sent in the past. So users who showed interest are listed in source segment. And you expand into users who show similar attributes, and you can send ads to such users so that you can send ads to users who have potential to show interest but are not yet friends. So let me summarize. As I have talked about, in the development of message event tracking system, there were some challenges, but we have overcome them, and we have created a scalable and robust message event tracking system. Moreover, based on this system, we are also developing various functions. Thank you very much for your attention.